And we have some rules regarding the discriminant. So when b squared minus 4ac is greater than 0, we have two distinct roots, meaning when we have positive value for the discriminant, we are going to get two distinct roots. For b squared minus 4ac is equals to 0, we are going to get two equal values, or we can say two equal roots. Okay. And again, for b squared minus 4ac is lesser than 0, meaning it has a negative value, we are going to get no solution, or we can say we are going to get no roots at all. So that's a basic overview of what we discussed in the previous exercise. However, if you want to clarify your concept, then I would recommend please do watch the previous lecture. Okay, so jumping into question number 2, we have find the values of k for which x squared plus kx plus 9 has two equal roots. And when they told us that we have two equal roots, what we can do is use the discriminant to our advantage. How do we find the discriminant? First of all, by identifying the a, b, and c values. So we all know the quadratic equation's general formula, ax squared plus bx plus c is equal to 0. So the thing is, for now, whatever is the coefficient of x squared is going to be called a, whatever is the coefficient of x is b, and whatever is an independent value, which means it's standing on itself and it is not the coefficient of anything, it's going to be c, or the constant. So a is equal to, for now, the coefficient of x squared, which is 1 in this case. B is equal to k, and c is equal to 9 itself. So just input this into our equation, which is the equation of the discriminant. B squared is k squared minus 4 multiplied by a, which is 1, multiplied by c, which is 9. Is what they've told us, it has two equal roots, meaning when there are two equal roots, we have the value discriminant equals to 0. So k squared is equal to 9 fours 36. So it's equal to positive 36. So k is equal to under root 36, and which in return is equal to k is equal to positive or negative 6. And the reason why we write positive and negative 6 is because 36 could be made by multiplying 6 multiplied by 6, or it could be even made by multiplying negative 6 multiplied by negative 6. That would be also equal to positive 36. So that's why we take both values in consideration, positive and negatives. That's one of the basic rules of math. Whenever you open an under root, mostly take the value which both values, positive and negative. Okay, for question number 3, we have kx squared minus 4x plus 8. It's kind of the same question. What we are going to say is our value a is equal to 3, b is equal to 2, and c is equal to k. Again, k is the constant. It is not the coefficient of anything else. Sorry, not in this. Oh, I just copied the wrong question. A is equal to k, b is equal to negative 4, and c is equal to positive 8. So these are the three values according to the equation. So again, make up the equation of the discriminant through this. Negative 4 squared is 16, positive 16, minus 4 multiplied by a, which is k, multiplied by c, which is 8. And that is going to be greater than 0 because it has two distinct roots. So it's going to be a positive value. Okay, so if we just simplify this up, 16 minus 8 fours are 32, k is greater than 0, 16 is greater than 32k. So we can say that k is actually, wait a second, we can say 16 divided by 30. Oh my, wait a second. 16 divided by 32 is greater than k. And if you simplify this, we are going to say that 1 upon 2 is greater than k, if I'm not wrong. Yes, so this is the correct equation. Let me just erase some of it so that I can get space for question number 4 and 5. K is greater than 1 upon. Wait a second. By the way, K is lesser than 1 upon 2. My bad, my bad, my bad. So K is lesser than 1 upon 2. Question number 4, we have find the values of 3x squared plus 2x plus k, which are equals to 0 and has no real roots. So whenever we have no real roots, we have no solution, and whenever we have no solution, we have a negative value for the discriminant. So again, identify the variables of the discriminant. A is equals to 3, B is equals to positive 2, and C is equals to K, the constant, because it is independent and is not the coefficient of anything. So what we are going to say is B squared, which is 2 squared 4, minus 4 multiplied by A, which is 3, multiplied by C, which is K. And it is lesser than 0 because it has no real roots. So 4 minus 4, 3 is a 12K is lesser than 0. So negative, 4 is lesser than positive 12K, and 4 divided by 12 is lesser than K. So 1 upon 3 is lesser than K is our answer for question number 4. For question number 5, what we have is find the values of K for which K plus 1x squared plus Kx minus 2K has 2 equal roots. So this is the point from which it's going to get a little bit tricky, but it's obviously not as hard. So K plus 1 is going to be the A value because it is the coefficient of x squared. So we are going to take K plus 1 as a whole for A. Again, it's not K plus 1 whole squared. K plus 1 is itself A. For B, we have K, and C, we have negative 2K, because negative 2K itself is not a coefficient of anything else. So what we are going to say is B squared, which is K squared, minus 4 multiplied by A, which is K plus 1, multiplied by C. First of all, K squared minus, instead of negative, it's going to become 8K multiplied by K plus 1. And this is, so it has 2 equal roots. When it has 2 equal roots, it's going to be equals to 0. So K squared plus 8K multiplied by K is 8K squared plus 8 ones are 8. So 8K is equals to 0. So 9K squared plus 8K is equals to 0. We take K as a common for now. 9K plus 8 is equals to 0. And we can say K is equals to 0, or 9K plus 8 is equals to 0. And the reason why we just do this really basic is because what's happening when we get some value equals to 0? When we get any value equals to 0, we can say 2 multiplied by 0 is equals to 0, and 0 multiplied by 2 is also equals to 0. So we can say that this one value, when multiplied by 0, the whole equation becomes equals to 0. I know it's a bit confusing for now, but still, that's my point. So K is equals to 0 and 9K plus 8 is equals to 0. What we're going to say, 9K, in fact, 9K is equals to negative 8, and K is equals to negative 8 divided by 9. So whenever we have K is equals to negative 8 upon 9, or we have K is equals to 0, we are going to get 2 equal roots. And that's it. That's the answer for question number 5. Proceeding on to question number 6. For question number 6, and they have told us find the values of K for which Kx squared plus 2K plus 3x plus K is equals to 0. So what we are going to do is say the coefficient of x squared is equals to K. So it's going to be A. B, we are going to write 2K plus 3 as a whole. Okay, because 2 multiplied by k plus 3 itself is the coefficient of x. So we are going to directly write it here. And the constant is for now k. So again, we write the equation b squared. What we're going to do is just independently square this up. 2 squared is equals to 4, and k plus 3 is in a bracket, so we have to square it as a whole. K plus 3 whole squared and 2 squared is equals to 4. Minus 4 multiplied by a, which is k, multiplied by c, which is again k. So we are going to get this value has two distinct roots. So that means it is a positive value and greater than 0. So for a squared is k squared plus 2 multiplied by a multiplied by b plus b squared. Sorry, plus 3 squared minus 4k squared is greater than 0. Simplify this up, 4k squared plus 3 to the 6k. 6 multiplied by 4 is equal to 24k plus 9 multiplied by 4 is equals to 32. Minus 4k squared is greater than 0. So my 4k squared minus 4k squared is equals to nothing. So 24k is actually greater than negative 32. Simplify this and we're going to get k is greater than negative 32 divided by 24, which in return k is greater than negative 32 upon 24 is going to be negative 4 upon 3. So that's it for question number 6. For question number 7, we have find the values of k for which 3x squared minus 4x plus 5 minus k is equals to 0. Many students get confused in this type of question in for what is going to be the constant. So as you can see, the coefficient of x squared is 3, so we are going to write it as it is. For b, it is negative 4. And for c, we have 5 minus k. And as we can see that neither 5 nor k is the coefficient of anything else. It is independent. So we can say that 5 minus k as a whole is the coefficient, is the constant of this equation. So that's it. Now construct the discriminant equation. Negative 4 squared is equal to 16 minus 4 multiplied by a, which is 3, multiplied by c, which is 5 minus k. Simplify this. 16 minus 4 3 is 12. 12 multiplied by 5 is equals to 60 plus 4 8. Okay. Wait a second. It's 4. Yes. So 16 minus 60 is equal. And by the way, again, this has yes, it has two distinct roots. So that means it is going to be greater than 0, or it is going to have a positive value. So 16 minus 60 plus 4k. So it's going to be 16 minus 60 is negative 44. So 4k is greater than negative 44. Positive 44. Because 16 minus 60 is negative 44. When it goes on the other side, it's going to become positive 44. And I think I've done some mistake here. Oh, sorry. 4 3s at negative 4 3s at 12. 12 multiplied by 5 is negative 60. And multiplied by negative k is going to be equals to positive 12k. Again, that's a mistake. And we are going to replace 4k by positive 12k. So k is actually lesser than 44 divided by 12. And k is greater than 44 divided by 12 is equals to 11 upon 3. So k is greater than 11 upon 3. And we can say, in other words, whenever the value of k is greater than 11 upon 3, we are going to get two distinct roots for our equation. Proceeding on to question number 8, we have find the values of k for which 4x squared minus k minus 2 x plus 9 is equals to 0 has two equal roots. So the thing is, the coefficient of x squared is equal to 4, so it's going to be written as it is. However, negative k minus 2 has to be written as a whole, because if we see in our quadratic equation, what's the general formula? Ax squared plus bx plus c. So whatever value is instead of negative, we are going to, whatever value is instead of the positive sign, we are going to write it in our equation. So if even though we have k minus 2 as a whole here, we take the negative symbol along with it for the coefficient of x for now, because it's not because in the general formula it has a positive value. So if it is having a negative value here, take the negative value along with your um variable. So c, and the constant is 9, as we can see here. So for now, what we're going to say is multiply this. So this is going to become negative k plus 2. And if we just rearrange this, this is going to become 2 minus k. So we can say b squared is going to be 2 minus k whole squared minus 4 multiplied by a, which is 4, multiplied by c, which is 9. And they've told us that it has two equal roots. So that means this discriminant is equals to 0. So again, solve this up real quick. 2 minus k whole squared is what's a squared, which is 4, minus 2 multiplied by a multiplied by b plus b squared, which is k squared, minus 4, 4 is 16, 16 multiplied by 9. What is 16 multiplied by 9? It is equals to 144. Is equals to 0. So 4 minus 2 to the 4k plus k squared minus 144 is equals to 0. Rearrange this. K squared minus 4k minus 140, because negative 144 plus 4 is equal to negative 140. So this is equals to 0. Let me just erase some part of this. Wait a second. Yes, let's continue from it. So question number 8 continued. So k squared minus 4k minus 140. What we do is take the LCM for 140. 7 2 the 14. 2 0 7 0 is 0. 2 tens and 2 fives and 5 ones. We have to make out a negative 4 out of this. 7 2 the 14, 5 2 the 10. So if we just take this up, k squared minus 14k plus 10k minus 140 is equals to 0. So again, k as the common here, k minus 14 plus 10 as the common here, k minus 14 is equals to 0. So we can say k is equals to negative 10 and k is equals to positive 14. So for these two values of k, we are going to get two equal roots from this equation. And that's it. This is it for question number 8. For question number 9, we have find the values of k for which 4x squared plus 4 multiplied by k minus 2 x plus k has two equal roots. Again, identify the variables for the discriminant. A is equals to 4, b is equals to 4 multiplied by k minus 2 as a whole, and c is equals to k, which is the constant. So b squared, we are going to square these two independently. So 16, 4 squared is 16, multiplied by k minus 2 whole squared, minus 4 multiplied by a, which is 4, and c, which is k. And what they have told us, it has two equal roots, so it's going to be equals to 0. So 16 multiplied by open this up, a minus 2 whole squared, sorry, a minus b whole squared is equals to a squared minus 2ab plus b squared. That's the general formula. So we can say that wait a second. So k squared minus 2 multiplied by a, which is k, multiplied by b, which is 2, plus b squared, which is 4. 2 squared is 4. Minus 4 for the 16k is equals to 0. 16k squared minus 2 to the 4k. 4 multiplied by 16 is equals to, what's 16 multiplied by 4? 64. 64k plus 64 minus 16k is equals to 0. So we are going to get 16k minus 80k, 64 plus 16 plus 64 is equals to 0. 16k squared, by the way. So 16 as the common, we are going to take k squared. You could directly solve this if you want, but it's going to make your life easier if you take the common here. So k squared minus 5k plus 4 is equals to 0. That would be ultimately equals to k squared minus 5k plus 4 is equals to 0, because 0 divided by 16 would be equals to 0. Just in order to solve this up, k squared, we take this 4, make the LCM 2, and 2 is the answer. So k squared minus 4k minus k plus 4 is equals to 0. So we take we factorize this up. We are going to get k multiplied by k minus 4 minus 1 multiplied by k minus 4 is equals to 0. So k minus 1, k minus 4 is equals to 0. So we can say we have two values for k. K is equals to 1 or k is equals to positive 4. For these two values of k, we are going to get two equal roots in our answer. And that's it for question number 9. Now, the thing is, question number 10 and question number 11 are a bit different. What they're asking us in this question is that we have to show that the roots of the equation, this, and this, are real and distinct for all real values of k. So basically what they mean is, for all real values of k, we have to prove that this equation is real and distinct. So right now we do not have to solve the equation. However, we just have to prove that the equation, or we can say the discriminant of the equation, is greater than 0, so that it obviously gives two distinct values. So when it's greater than 0, it's going to have a positive value. So for that, what we do is, first of all, find out the equation of the discriminant. How do we find out the equation of the discriminant? So we have question number 10. A is equals to 1, B is equals to k minus 2, and C is equals to negative 2k. So these are the three variables for the discriminant. B squared is going to be k minus 2 whole squared minus 4 multiplied by A multiplied by C. And what they've told us, they are real and distinct values. So which means that they are greater than 0. So again, k minus 2 whole squared plus 8k is greater than 0. Till now, we do not have any proof that this is going to be a value which is greater than 0. So what we do is solve this up for a bit. So k squared minus 4k plus 4. That's it. So if we open k minus 2 whole squared, we are going to get a squared minus 2 multiplied by a multiplied by b, which is 2 multiplied by k multiplied by 2, and that is going to give us negative 4k plus b squared, which is positive 4. And again, plus 8k is going to be written here, which is lesser than 0. So we are going to say that k squared minus 4k plus 8k plus 4 is greater than 0. K squared minus 4k plus 8k. So it's going to become positive 4k plus 4 is greater than 0. Now this step, what we are going to do is make this again into a squared equation by using the completing the squared method. So how do we do that? We say k squared plus 4k plus 2 squared is greater than 0. And then obviously what we do is 2 here. So we say k plus 2 whole squared is greater than 0. If you do not know how to solve, use the completing the square method, watch my previous lectures. I have explained that in great detail. So what we are going to do, k plus 2 whole squared is greater than 0. We have this equation. And we all know that general formula of the parabolic equation ax minus h whole squared plus k. And when we have this equation, we can say that the h value and the k value in this is the maximum or the minimum point of the parabola. So for now, what we have is positive 2. So h is equals to positive 2 here, and k is equals to 0 because we do not have any value here. We can also write plus 0 here. Okay. So we can say that the x value and the y value of the maximum slash lowest point is 2 and 0. However, if I were to plot a graph like this, I would choose x equals to 2 and y is equals to 0. So this is, for example, this, let me just make it more clearer. So this is 1 and this is 2. This is 1, this is 2, all and all the way forward. So x equals to 2, y is equals to 0 would be this point. And if we would draw a parabola, it would be something like this. Okay, so I know that it's a little bit rough, but it's just for your visualization. As you can see, for this parabola, the minimum point is at the point 2, 0, as we find out from this equation. So that means that it is almost just, wait a second, yes, it's touching the x-axis, but it's not at all going below it. So it's greater than 0. It's not a value which is negative. So we can say that yes, it has distinct roots, and we can also add real here. Distinct, distinct roots because the minimum point for the graph is greater than 0. Okay, so that's it. We said that we have proved this because the minimum point for the graph is greater than 0, and as we have shown in this solution. So that's basically it for question number 10. It's in fact, we may say that it's more tricky than finding out the values of k because we have to prove how we have done it and how to solve it. So that's basically it. So for question number 11, it's much more simpler than question number 10. What they've told us is show that all roots for the equation kx squared plus 5x minus 2k is equal to 0 are real and distinct for all values of k. So again, it's real and distinct, which means the values are going to be positive and are going to be greater than 0. Specifically, what values are going to be greater than 0? The discriminant is greater than 0. So first of all, find out the variables of the discriminant. A is equals to k, b is equals to positive 5, and c is equals to negative 2. Okay. So solve this up. B squared is 5, 5 is 25, minus 4 multiplied by a, which is k, and c, which is again negative 2k. And again, as it has two distinct roots, we're going to say it is greater than 0. So 25 minus 4 2 is 8, negative positive 8k squared is greater than 0. So we can say that this value is, yes, it's greater than 0. How? Well, 25 is a positive value, okay? 8 itself is a positive value, and k squared always is going to be a positive value, because when we have a squared, any value which is trapped under squared will become a positive value. For example, we write negative 2 squared, it's going to become positive 4, because negative multiplied by negative is going to give us positive. So whatever, even if it's a negative value in k, in the end it's going to give us a positive value after it is squared up. So that's why we can say that k is always going to output a positive value. K squared is always going to output a positive value. K 8 is already positive and 25 is also positive. So we can say, yes, this equation gives two real and distinct roots as it is positive when solved. And that's it. This is how we show, or we can say we prove, that this equation is greater than 0 and is giving two real and distinct roots. So that's it. This is for exercise 2.5. I will meet you in the next lecture with exercise 2.6. Till then, thank you.